right. Hello, welcome back. Happy New Year, and welcome to another physics video lecture. Today, we're going to be talking about mechanical energy. All right, so let's dive right in. So we've already learned about the conservation of energy, okay? What this means is that energy in this universe can never be created and it can never be destroyed. It can only be transformed from one form into another, okay? The total amount of energy that we had at the beginning of the universe, starting with the Big Bang, is the exact same amount of energy that we have now, but that energy just changes forms, right? From chemical to potential to electrical to kinetic and so on. The only two forms of energy that we've talked about so far are potential energy and kinetic energy. So let's look at those again, right? Potential energy, if something has potential, that means it has the ability to do something, right? So in this case, potential energy is stored energy. It's energy that is stored that can be used later, that can be turned into another form, okay? The only type of potential energy that we've talked about is gravitational potential energy, and it's called gravitational potential energy because it happens when something is lifted off the ground, and if it's dropped, gravity turns that potential energy into kinetic energy. Like for example, right, you pick something up off the ground, it's gaining potential energy, now it has stored energy, and if I let go, right, that stored energy transforms into the energy of motion. We remember our equation for gravitational potential energy is pretty easy. You take the mass, multiply it by little g. Remember, go back to your reference sheet, little g, 9.8 meters per second squared. It's always with you. Write that down if you don't have it written down already. And then h, which is just the height. So to find this, all you need to know is the mass of the object, the height off the ground, and remember that little g is always 9.8, which again is on your equation sheet. Okay. So again, this should be an easy question. What happens to the potential energy when the roller coaster falls down the hill? Potential energy is converted into kinetic energy. Pretty straightforward, right? So what is this kinetic energy? Simply put, kinetic energy is the energy of motion. Whenever anything is moving, it has kinetic energy. That's what kinetic means. It just means movement, okay? Any object with velocity has kinetic energy. If you have a velocity and a mass, which pretty much everything has a mass, in this realm, we'll actually say everything has mass. You have kinetic energy, right? Because our equation, again, is 1/2 times the mass of the object times its velocity squared. So if you have a velocity, you have kinetic energy. And like all forms of energy, I didn't say this last time, we measure all of this in joules. So kinetic energy is measured in joules. Potential energy is measured in joules. In work is actually measured in joules. So we'll keep seeing this pop back up. Cool? Okay, so these should be in your notes already. If you don't have them, write down about potential energy, write down about kinetic energy, write down about the law of conservation of energy. You need those 3 pages. Okay, so new for today, okay, this is going to come out, I don't think I have this popping down, this might come all at once, is we're talking about total mechanical energy. Okay, now this may sound complicated, but it's really just combining what we know about potential energy and kinetic energy into a pretty easy equation. All right, total mechanical energy is the total amount of energy in a system. It's all of the energy added up, okay? So to find this, the equation that you have, and this is on your equation sheet, is the following. Mechanical energy equals all of the potential energy in the system plus all of the kinetic energy in the system. That's it. If you're looking at something, you take its potential energy, you add its kinetic energy, you get its mechanical energy, all right? So as we go forward, we're gonna do a couple problems. You're gonna have to do some substitutions. So this equation, which you're given, becomes this equation. You're not given this, but you're given these 2 equations, right? Potential energy is mass times little g, 9.8, times height. Kinetic energy is 1/2 the mass times the velocity squared. Add those up, and that gives you your total mechanical energy. Okay? Energy is always conserved, so your total mechanical energy of a system never changes. Okay? What changes is how much potential energy or how much kinetic energy you have. Okay? And we'll kind of see this as we go through a couple examples. And the types of energy change from one form into the other. They go from kinetic into potential, or potential into kinetic. Okay? So let's look at some examples of this. All right? So here we have how much mechanical energy we have, how much potential energy we have, how much kinetic energy we have. And they're always going to add up. Okay? So here's our equation that we just had. So let's look at an example. If I have 5 joules of potential energy and 15 joules of kinetic energy, how much potential energy or how much mechanical energy do I have? Now the point of this chart, okay, is to see it as such. If we were to call these, let's say that we have, 5, 10, 15. Let's say these are all, and this is all in joules right here, okay? So if I have 5 joules of potential energy, right? I have 5 joules of potential energy. I have 15 joules of kinetic energy. Right, fill in all these, right? How much mechanical energy do I have? Well, all you have to do, right, is we know mechanical energy equals potential energy plus kinetic energy. So you just add them up. If you want to see this mathematically done, right, you would have ME equals PE plus KE. Add them up. Your potential energy is 5, so ME equals 5 plus your kinetic energy is 15. Well, solve this, right? 5 plus 15. Hopefully you're way ahead of me here. It's 20 joules. So in our chart here, we'd have this much. Sorry that my scribbles are not super cohesive, but look, it's saying the same thing. This column equals this column plus this column. 15 plus 5 equals 20. Does that make sense? Right? And this is kind of what I was getting at. The total mechanical energy here will always stay the same, but your potential energy and your kinetic energy will get bigger and smaller. The more potential energy you have, the less kinetic energy you have. The more kinetic energy you have, the less potential energy you have. All right, let's see another example of this. Okay, I'm just going to do these mathematically now. All right. So if my mechanical energy equals 20 joules, my kinetic energy is 2 joules. How much potential energy do I have? Again, mechanical energy equals potential plus kinetic. So plug in your numbers. My mechanical energy is 20. That equals my kinetic energy, which is 2. And I'm looking for how much potential energy do I have. Well, this is like any other problem we've done. We're trying to get potential energy by itself. Here we have addition. So we have to do the opposite of addition, which is, you guessed it, subtraction. Whatever I do to this side, I do to this side. 2 minus 2 is 0. 20 minus 2 gives us a potential energy of 18 joules. Hopefully this is looking pretty straightforward. Okay? My total amount of energy is 20. If I got 2 joules of kinetic energy, I have to have 18 joules of potential energy. As you see, potential energy got bigger, so kinetic energy got smaller. Okay? Here, same thing. Let's see if you can get this one, all right? Let's see if you can get this one by yourself. I got 20 joules of mechanical energy, 9 joules of potential energy. How much kinetic energy do I have? What'd you get? Let's look. Our mechanical energy is 20. Our potential is 9. We're looking for KE. We're going to add these. This is addition, so we have to do the opposite, right? We're trying to get K by itself. We're going to subtract 9. Whatever we do to that side, we do to this side. 9 minus 9 is 0. And 20 minus 9 gives us 11 joules of potential energy. Or kinetic energy, excuse me. 11 plus 9 equals 20. Pretty straightforward, right? Not insanely complicated. Okay? So let's look at this from a few different angles. Let me show you a couple little simulations here. All right. This simulation I love, okay? And this is really helpful because what you see happening is you see a ball swinging back and forth on a pendulum nice and slowly. You will notice that the height of the ball is changing. It's getting higher, 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 going up to 2, okay? And then, do I have to hit play again? There we go. And then it gets lower, 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 okay? And as you're watching it, you can see the height change. You can see the velocity of the object changing. We're calling this a bob, swinging back and forth. And you can see its potential and its kinetic energy changing, okay? Now the cool thing about this is that the total amount of energy doesn't change, right? Notice we get a total amount of kinetic energy, we get a total amount of potential energy, okay? And they go back and forth, all right? Which I think is super cool. So what you'll notice is when it's at the very top, its potential energy is the highest, and when it swings down, it's going faster and faster and faster and faster. As it speeds up, its kinetic energy gets higher and higher and higher. As it goes back up, its potential energy gets higher, and swings back down, its kinetic energy gets higher, right? As one gets bigger, the other has to get smaller. The faster it's going, the lower it gets. The higher it's going, the more it slows down. Okay, so let's look at these three instances here. All right, so here we have A, B, and C. Throwing a ball up into the air. At point A, when the ball comes right out of your hand, the second it comes out of your hand, okay, we're gonna say that this is the level of the ground, okay? So as soon as it comes out of your hand, all it has is speed, which means as soon as it comes out of your ground at point A, all we have is kinetic energy. But as it goes up, it's gaining height. So now, it's going up, and halfway up, the ball is moving, and it still has a height, right? It's because it's going above the ground. So at B, we're going to have 50% kinetic energy, because the ball's moving, and 50% potential energy, because again, it's above the ground. Now, as we move all the way up to the highest point, when it gets up to the highest point, it has all height, and as we know, it changes directions, which means that its velocity is 0. So at the top, it has all potential energy and no kinetic energy. Again, when the ball falls down, okay, when it gets to B, again, it has 50-50 kinetic and potential because it's still moving, and it's speeding up, so when it gets back to A, it has no more potential energy and 100% kinetic energy, okay? Potential energy comes from height off the ground, so the higher it is, the more potential energy it has. Kinetic energy comes from movement, so the faster its velocity, the more kinetic energy it has. All right, we just saw this. Hopefully this is pretty straightforward. Where does it have the most kinetic energy? Do you remember? Very good. Correct answer here is 3. This is where it's going the fastest. How do I know that? Well, look, as it goes down, it's speeding up, speeding up, speeding up, speeding up because of gravity. It gets to 3, and then it starts going up again. What happens when it goes up? Gravity slows it down, so it's going slower and slower and slower. 3 has the most kinetic energy. Where does it have the most potential energy? Well, that's where it's the highest. You should remember, is 1 and 5. So let's do a couple problems real quick to show you how to do this mathematically, all right? Okay, so mathematically, we have a dog jumping into the air, okay? So let's write down what we know. This dog has 400 joules of potential energy and 800 joules of kinetic energy. How much mechanical energy does it have? Well, if you remember, we can always write down our equation first. So our equation here is mechanical energy equals potential energy equals kinetic energy. All right, we got everything we need. Plug your numbers in. Mechanical energy equals 400 joules of potential plus 800 joules of kinetic. All right, just plug them in. Boom. 400 plus 800 gives me a total mechanical energy of 1,200 joules. Okay? So some of these are going to be really simple. Okay? It's just going to ask you what the total mechanical energy is. Well, you just add them up. Add up the potential energy, add up the kinetic energy. Bob's your uncle. All right? So let's look at a slightly more challenging problem. All right, so now we have a skydiver falling to the ground, right? So in this case, the skydiver is moving because they're falling, and they're above the ground. So they're going to have both potential and kinetic energy. Let's solve this. So we know the skydiver is 72 kilograms, so our mass is 72. We're falling at 54 meters per second. Velocity is 54 meters per per second. Find their total mechanical energy when they are 10,000 meters above the ground. So I know our height is 10,000 meters, and we're looking for the total mechanical energy. All right, this may seem weird and convoluted, but let's go back to our equation. Our equation for mechanical energy is equal to potential energy plus kinetic energy. All right, so in this case, all we have to do is solve for potential and kinetic. So again, go back to your equation sheet and remember, in fact, let me do this. Potential energy is equal to mass times gravity times height. And kinetic energy, in fact, let me move this just down here. Mechanical energy is equal to mass times gravity times height. I'm going to put that in parentheses. And we're going to add that to our kinetic energy, which is equal to 1/2 times mass times the velocity squared. Well, let's plug our numbers in and see if we got everything. So in here, mechanical energy is equal to mass, which is 72, times little g, which is always 9.8 meters per second squared, times my height, which is 10,000, plus 1/2, which remember, I always do 1/2, is 0.5, times the mass, which is 72, times my velocity, which is 54 squared. Now notice, I got a lot of numbers going on, but my only variable is right here. So all I gotta do is put these bad mamma jammas into the calculator, and we're good to go. So go over here and grab my calculator. Yay! Almost everything is in play here. You can see almost everything. Okay, almost. So let me enter in this up here just so you can see. Okay, so step number 1, first parentheses, 72 times 9.8 times 10,000. Well, look at this. I can actually just put this all in so long as I use the parentheses. So watch this. Parentheses, I got my mass, 72 times 9.8 times 10,000, 10. I'm going to close this parentheses. Now I'm going to add it. See my addition right there? Plus, and we're going to do the other step. So close parentheses, 0.5. 72, which is our mass, times our velocity, which is 54, and don't forget to square it. Squared. We go forward, and close parentheses. I don't even need to hit enter, because my answer on this lovely website is right here, and the answer is 7,160,700, or 979 joules. And all this is your potential energy plus your kinetic energy. Mass times little g times height plus 1/2 mass times the velocity squared. I call this 7.1 times 10 to the 6. Right? So this would be my answer. Mechanical energy, 7.1. Beautiful. Oh. Okay. So now you can see that you can find your total mechanical energy if you just know the mass, the velocity, and the height. What if we want to get a little weirder with it? Okay. In this case, let's see what we have here. So I know that this roller coaster, I know the mass of the roller coaster is 8.5 times 10 to the 5th kilograms. Look familiar? It should. And it's 20 meters above the ground, so that's its height. And I know that it has a kinetic energy that is equal to 9.5 times 10 to the 7th joules. I want to know how much mechanical energy it has. Okay, let's solve this. How do we do this? Well, again, I'm going to put this equation down here. Mechanical energy equals kinetic energy plus potential energy, or potential energy plus kinetic, if you want me to stay. Potential energy plus kinetic. Okay, so I fill these two in, which means my mechanical energy equals mass times gravity times height, plus the kinetic energy, which, guess what? They already gave me. I already know that one. Plus 9.5 times 10 to the 7th. Beautiful. So all I got to do is plug in my mass, gravity, and height. Well, let's see if I can do that. Mechanical energy equals the mass, 8.5 times 10 to the 5th, times little g, 0.8, times the height, which is 20. Everybody see that? Mass times little g times the height. And we're just going to take that and add it to 9.5 times 10 to the 7th. Oh, great, right? So, again, mechanical energy is by itself, so we just got to stick this in our calculator. So jump back over to the calculator, clear all, and let's do it. So again, I'm going to go parentheses. And actually, I need to double my parentheses here because I have this. So this, you know what we're going to do? We're going to make this easy, and we're just going to solve this first bit by itself. So I'm going to go parentheses, 8.5 times 10 to the 5th power. I hit that a to the b. I'm going to go forward, close parentheses, times 9.8 times 20. This is everything I have right here. I'm going to hit enter. And then I'm going to hit answer, which gives me my answer from this one. And I'm going to add that to parentheses right here. Remember, this has to have parentheses. Technically, this has double parentheses. That gets kind of confusing. But if you do it one step at a time, it's really easy. 9.5 times 10, a to the b, 7th, forward arrow, close parentheses. My answer here is 261,600,000 joules. There's your answer right there. All right, let's do one more. The video's getting long. So I'll show you one more. Again, remember you can always pause, go back. Okay, a 5 kilogram cat, start right off the bat. Mass, 5 kg. Has a velocity, 10 meters per second. Very good. All right, if the cat has a, it's giving me the mechanical energy, 308 joules, 308.8 joules. How high off the ground is it? I want to know the height. Okay, so again, jumping right into it, we have our mechanical energy equals kinetic, or equals, should I get this right? Potential energy plus kinetic energy, okay? So I know the mechanical energy is, so if I write all this out, mechanical energy equals potential energy, mass times little g times height, plus 1/2 mass times velocity squared. Boom, boom. This is our potential, this is our kinetic. Sorry about the bad handwriting. So I'm going to write this down. So now if I plug everything in, I know my mechanical energy this time is 308.8. That's going to equal my mass, which is 5, times little g, which is 9.8, times my height, which is what I'm looking for. We're going to add that to 1/2 times the mass, which is 5, times the velocity, which is 10 squared. Again, same as before. I wrote out my equation and I plugged my numbers in. My mechanical energy is 308.8. My mass is 5. Little g is always 9.8 meters per second squared. And I'm looking for my height. So do not be confused here. This is what I want. I want this H that looks like a sad saxophone. I apologize for that. We add that to our kinetic energy, which is 1/2 times the mass, which is 5, times 10 squared. Now, what do? First thing you do is regular math. Okay, so the first thing I'm going to do is do all this. So let's grab our calculator. So the first thing I want to do is clear this. And I want to do 5 times 9.8. 5 times 9.8 is, answer, 49. So the first thing I do is bring all this down here. So now I have 308.8 is equal to 49 times the height, plus, clear this, 1/2 times 5 times 10 squared. So remember, so we have 0.5 times 5 times 10 squared. This is what I have right here. Remember, 1/2 is 0.5. Multiply that by 5, the mass, 10 squared. This gives me an answer of, 250. Okay? So let me go back over here. So now I have 49 times the height plus 250 equals 308.8. So I want this h by itself. First thing we got to do is get rid of this 250. This is addition, so we're going to do the opposite of addition. I subtract, so I minus 250 from both sides. 250 minus 250 is 0. 308.8 minus 250 gives me 58.8, and that equals 49 times h. Sorry about that. Now, I know it's kind of hard to see at the bottom. H is right there. So I want the h by itself. This is multiplication, so I got to do the opposite. I got to divide both sides by 49. 49 divided by 49 is 0. And we just go back to our calculator and clear. 58.8 divided by 49. Enter. Answer is 1.2. And again, if you're like, why are you hitting that answer button, Mr. Norris? I'm just doing that so I can bring it over. But if you scroll up, as soon as you put that in there, it gives you the answer right here. You could actually turn it into a fraction. Isn't that fun? But that's our answer. 1.2. So our height here is 1.2. And it's a height, so it's meters. Oh. All right, guys. That's everything you need to know about total mechanical energy. Use this to crush today's DOL. And as always, if you have any questions, email me, find me at tutoring, reach out. I'm here to help. Okay? Have a great day.